Greetings, my name is Hardik Raj and today we will be discussing the problem form of web. This is a simple level problem and the prerequisites are primes and prime gap. Let's move on to the problem. Okay, the problem states that we are given two integers x and y. They both are less than or equal to 2000 and we have to find a prime number which is greater than x plus y. So we have to find a prime number which is greater than x plus y, and we have to output this prime number, let's call it p. So we have to output p minus x plus y. Let's move on to the solution. Okay, now as for the solution, one thing that you should know and that is not at all intuitive is a prime gap. So what is a prime gap? This basically for numbers less than or equal to 10 to the power 9, the gap between any two primes is 292. This is the maximum prime gap. Sorry, not exact prime gap, the maximum prime gap. What I mean is, if you have a prime number p, then at a gap of 292, you will get at a maximum gap of 292, you will get another prime. So p plus 292. In this range, you're definitely bound to get a prime number. Well, let's take a few examples. Say we have 2 and the next prime number is 3, the next prime number is 5, 7, 11, 13, 17. So for prime gaps, here the prime gap is 1, here the prime gap is 2, here it's 2, here it's 4, here it's 2, and here it's 4. So had you taken 2 and in the range 2 to 292 plus 2, that is 294, you're definitely bound to get a prime number. You can read more about it on Wikipedia. I will provide the link in the description. So yeah, uh, you need to know this fact before moving on to the solution. Now as for the actual solution, what we will be doing is we are given x plus y and we want to find a prime number that is just greater than x plus y. So we will keep iterating from x plus, we will keep an iterator, and this will move from x plus y plus 1 till we find a prime number. And if we find a prime number, we will just output prime minus x plus y. And as of finding whether a number is a prime or not, we will use the square root method. This is a lot of information to take in. Let's look at the code for a better understanding. Here I am taking t as the number of test cases and I am calling the solve function. So int x comma y, this is our two given inputs. Take the input and this is our current sum or the given sum. Now we want to find a number which is greater than x plus y and which is also a prime number. So we will run a for loop from given sum plus 1 until we find a prime number. That is why I have not written in terminating condition over here. And we'll keep on incrementing the current number until we find whether the current number is prime or not. Now we need to check if the current number is prime. So I've called a helper function is prime. It returns whether the number is prime or not. For finding whether a number is prime or not, we use the square root method. So we run a loop from I equal to 2 till square root of num, that is our current number, and if we are able to find a factor, then that means the number is not a prime number. We output false, otherwise we return true. And if our current number is indeed a prime number, or we can simply write it as true, this is something that is supported in C++, we just need to output the prime number minus the given sum. So let's try to submit this. Well, it takes a it takes a few time to submit, but the main takeaway from this problem is that you should know what a prime gap is. Okay, so this was submitted. Now let's look at the time complexity. This is very important. Otherwise, any question is incomplete without a time complexity. So, okay. Now for time complexity, we are iterating over the prime gap. We know that the maximum prime gap is 292. Okay, and for each number in this prime gap, we are checking if the number is prime or not using the square root method. So this take square root of n time. This is for a single query, and there are t test cases. So the total time complexity is t into 292 into square root of n. One more thing, that I said that the maximum prime gap is less than equal to 292 if the numbers are less than 10 to the power 9. But in our case, the numbers are less than, see, the x was less than equal to 2000 and y was also less than equal to 2000. Then x plus y is less than equal to 4000. So we need to find a prime number that is just greater than 4000. And as per this table, here for a prime number greater than 4000, okay, from 1300 to 950 9551, the maximum prime gap is of 34. So this we won't be running this for 292, but rather we will be running this for at most 40 iterations, or it was 34 to be exact, but just for safety, take this 40. So the total time complexity is t into 40 into square root of n. This is the time complexity. I hope you understood the solution and see you next time. That's it for this one. Like the video if you understood the concept. In case of any feedback or doubts, please feel free to drop a comment below. Do try and submit your own code on CodeChef after watching this tutorial. If you're interested in competitive programming and want to learn and master data structures and algorithms, then CodeChef is a one-stop destination for you. Every week we post CodeChef problem explanations, frequently asked interview problems, conceptual videos on various programming topics, and also conduct live problem-solving sessions. To stay notified of our upcoming uploads, subscribe to our channel and hit the bell icon below. See you next time.